There are several frequency bands that are used in digital communications, all somewhat slightly separated from variations in number of frequency. And one thing you need to know is that there's a thing called coherence and interference. These two principles um, ride on how we can use frequencies or if we can't use a frequency. Because if a frequency coherently interferes with another frequency because it's just slightly different or somewhat different, then that frequency could not be used in the same region as another device that uses a somewhat different, slightly different frequency. Because if it interferes with the communications, then it can't be used. This is why there are legal frequency communications rules. Because if you use a frequency that interferes with other people's frequencies, it's not legal. And also, frequencies can be dangerous. Devices that emit frequencies can be dangerous in your remote region. Some things like FM towers, radio towers, all different kinds of things, if they emit a leaky frequency in their amplification process, it can cast a bunch of deadly energy everywhere and cause people to get harmed. So, like, voltage is a serious thing, and only a slight amount of voltage in a tiny sensor is a lot of voltage over a large area. So, like, your whole body could be suffering from federal communications rule breakage. Like, there's too much bad frequencies that could be leaking and put onto you. Even when the air voltage says that it's a slight voltage on a tiny sensor, it could mean that your whole body is increasing in a significant amount of voltage. And frequency matters. Even if it's a visible spectrum, doesn't mean that just because it's a lesser frequency that it isn't more harmful. Or even if it's more, it doesn't mean that it's less harmful. Frequencies can be somewhat specific to the conditions of our world. It's not necessarily guaranteed that everything's just straight up the line with the power rating or the frequency. It could be a lesser frequency that causes more harm than a much stronger frequency or a higher frequency, a much faster frequency. So, frequency is specific. It's not always the same. But in some quantum sense, the more energy you can detect that it puts out based on the increase in frequency, if that's the case, then you should be able to say that something is relative to the increase in frequency proportional to the increase of energy and its effects. But this doesn't seem to be always the case.